Good morning, everybody. Today we're studying the review for test 2. Test 2 takes place tomorrow. There will be, I think it's 26. Yeah, 26 questions on test 2. We have 26 sample examples in the review. We're gonna prepare for them. You guys ready? Take good notes. The first problem, determine the number by which both sides of the equation must be multiplied or divide as specified to obtain just x on the left side. Okay, so let's look at the problem. Only look at the part that I highlighted in blue. Determine the number by which both sides of the equation must be multiplied or divided as specified to obtain just x on the left-hand side. To obtain x on the left-hand side means isolate x on the left, right? Right? Yeah. So basically, we are trying to figure out what number, for example, this one, the equation which is given is 3/2 times x equals 9. We are told we are going to multiply both sides of the equation by a number that we could isolate x on the left. Am I clear about? Yeah. That's what we're gonna do here. We're gonna multiply a number on both sides of the equation to isolate x. So what do you think? When we cover this part, I made you guys write down the sentence. When the coefficient of x is a fraction, we are multiplying the reciprocal of the coefficient. The coefficient of x is 3/2, right? It's a fraction, yeah. What's the reciprocal of 3/2? 2/3. So what you're gonna choose is 2/3. Okay, the answer, look at here. Answer is 2/3. All the 26 questions are multiple choice questions. So for the first one, you look at A, B, C, D. You are choosing the number which is the reciprocal of the coefficient of the x in the equation. Am I clear? So the first problem, you are choosing a number. That number is the reciprocal of the coefficient of x in the given equation. And the first problem is simple, but you do have to be clear. What are you looking for? We are looking for a number. We are going to multiply both sides of the equation by the number to isolate x on the left. Since the coefficient of x is 3/2 in the equation, the number we are going to multiply by is the reciprocal of 3/2, which is 2/3. So you're going to choose 2/3. Does that make sense? So you are not solving. Yeah, you are not solving. You are not looking for equation. You are not looking for the solution of the equation. Am I clear? Yeah, you have to read the problem, knowing what are you looking for. What's the goal? You are looking for the number you are going to multiply both sides of the equation by in order to isolate x. So you are not solving, okay? Am I clear? The first problem, you are not solving. You are choosing the number which is the coefficient, which is the reciprocal of the coefficient of x to isolate the x on the left. Because when we multiply 3/2 by 2/3, x is isolated, right? On the right, we have 9 times 2/3, but we don't have to care about that. You are not solving. Am I clear? Yes. Am I clear? Sorry. Yes. Kendall? The first problem, you are not solving the equation. You are looking for a number. You are going to multiply both sides of the equation by the number. To do what? To isolate the x on the left. Since the coefficient of x is a fraction 3/2, you are going to multiply the reciprocal of the number, which is 2/3, then you can isolate x. Okay, Angela, do you see that? Perfect. You guys see that? That's the first problem. It's an easy one. You are not solving, by the way. So when you take the test, if there's anything you are not clear, feel free to ask me. That's okay, okay? Number two, you are solving. Okay. So I'm going to erase the solution that I wrote here. Remember that. Okay, I'll give you 1 minute. Solve this equation. Number two, solve the equation x plus 2 equals 1. I'll give you 1 minute. You have 26 questions on the test 2. You have 55 minutes, so 2 minutes for one. And this is an easy one. Solve the equation. You are looking for the value of x that satisfies the equation. And which value would satisfy the equation? The main thing we learned from chapter 2 is to solve equation. And you will have a calculator. You will be allowed to use a calculator for test 2 tomorrow. So to be honest, there's no reason you do not get this kind of problem right. Because the worst case, you just plug in, right? You will have A, B, C, D. The worst case, you plug in the value, and then you plug in another value until you see the value that satisfies the equation. Okay, do you have the solution for the equation? Laura, are you all right? Yeah. What's x equal to? -1? Yeah, exactly. Awesome. It's 1, right? Ian, do you have the same thing? Yes. So once you have your solution, if you are not sure, you can always plug in. You can always plug in. Let's say you want to know if x equals -1 in solution, right? You can plug in. Replace x with -1. -1 plus 2 equals 1. That is a true statement, right? That means -1 satisfies the equation. Now let me show you how do we actually solve the equation. It is an easy equation to solve. When we solve the equation, we try to isolate x on the left, right? Isolate x on the left. Yeah. So in order to do that, do we need to get rid of the -2? You can move 2 over. We need to get rid of the +2, right? Excuse me. So you can move 2 over to the right-hand side. Yeah, so what happened here is you bring down x. Nothing has changed. It's still on the left-hand side. You bring down 1. It's still on the right-hand side. What have changed is the +2. This term. We move it from the left to the right. So the sign becomes the opposite sign, -2 on the right-hand side. Is that clear? Yeah. So that's so-called the transposition of terms, right? What is 1 minus 2? -1. That's the first method. That is one way you handle it. The other way to solve this equation for x, is you can -2 in order to get rid of +2 from the left-hand side. You -2 from both sides. +2 and -2 cancel each other, so you have x on the left by itself. On the right, 1 minus 2 is -1. Either way would be okay, right? I would say this is super straightforward. Yeah, number 2, solving the equation is super easy. Yeah, you can check the solution by plugging in the solution. in the equation. Any questions about number 2? Number 3. Number 3, again, you are not solving. You are not solving. You are looking for the number you are going to divide both sides of the equation by, such that you can isolate x on the left. Yeah, I would give you a little time. Please complete the requirement. That's the same thing you're going to see tomorrow in test 2. Determine the number by which both sides of the equation must be multiplied or divided as specified to obtain just x on the left-hand side. So here we are going to divide, right? And which number are going to be divided? Yeah, negative. Oh. Negative. So did you? Yeah, not a negative. Okay. We are going to divide both sides of the equation. I counted it in blue. We are going to divide this equation, both sides, by the coefficient of x. Coefficient of x is -10. You are going to divide both sides by -10 to isolate x on the left. Is that clear? Again, number 3, you are not solving. Yeah, tomorrow if you are not if you have any confusion, you are not sure what are you going to do in this problem, you can just ask me. Number 3, you are not solving. The answer is not a solution. The answer is the number you are going to divide the equation, both sides of the equation by, -10. Okay. Yeah, I did extra in the review. I posted. Did I post the review in Moodle yet? I might not, so I'm going to post that today. In the solution, I did more, but we don't have to do that. It's just the extra. You are choosing the number you are going to divide the equation by to isolate the x on the left. You are not solving the equation. Yeah, as I wrote here, be aware you are not solving the equation here. Okay, any questions? Any questions? No? All right, number 4, solve the equation. I'll give you a little time. Solve the equation, -x equals 4. The equation is -x equals 4. You are looking for the value of x that satisfies the equation. Yeah, feel free to share your answer. What's the answer? What x equal to? Huh? What is x equal to? Sammy, do you have an answer? Exactly. Exactly. Do you guys have the same thing? The value of x. This is a simple equation. Yeah, when we solve an equation, we try to isolate the x on the left, right? Once we have x isolated on the left, we would have the solution right away. On the left, now we have a -x. The coefficient of x is -1. So we are going to divide both sides of the equation by the coefficient of x, which is -1, right? Okay, -1 cancel -1. We have x isolated on the left. On the right, 4 divided by -1, we have -4. Make sure you will have a calculator tomorrow. If you don't have one, you can borrow a calculator from Student Success Center, use your student ID. But do that before you start the test. All right? Am I clear? Super good? Okay. Yeah, this problem is pretty straightforward, very easy. You can also understand this equation as this. The opposite of x is 4. The opposite of x is 4. So x is the opposite of negative. So x is the opposite of 4, right? So that is -4. You see what I'm talking about? And the opposite of x is a 4. The opposite of x is a 4. So x is the opposite of 4. Opposite of 4 is -4, so x is -4. So there are different ways to deal with this problem. Next up, number 5. Solve the equation. Let me write here, number 5. You are solving 3x plus 4x equals 42. I give you a couple minutes first. Yeah, you would have the feeling tomorrow. You would have the same feeling tomorrow when you see this problem. And you would know if you are able to handle it tomorrow or not. Give you a couple minutes. 3x plus 4x equals 42. I remember when we talk about this part, every time I draw a bubble, and write a sentence here, isolate x on the left. That's your goal. Yeah, that's your goal. Isolate x on the left. Yeah, you have the answer already? What is it? Perfect. Very good. Yeah, let me walk around. Let's see if you have. You can ask me if you're stuck anywhere. Awesome. Very good. Angela, what do you have? Perfect. That's the solution, right? That's awesome. So that's what it is. Okay. Yeah. Do you see the left-hand side? You can easily combine them. 3x, 4x can be combined as 7x, right? And you have a 3x, you have a 4x, you have 7 of them. Do you have an answer? Perfect. Very good. Awesome. Yeah. So most of you have this problem done correctly. We have a guideline. Remember when we learn this part, we have a guideline. The first step is to simplify each side of the equation separately. Right-hand side is already very simple. It's just a constant 42. Left-hand side, 3x plus 4x. Let me elaborate here. What is 3x? 3x means you have 1, 2, 3. 3x, that's it. And what is 4x? You have 1, 2, 3, 4. 4x, so together you have 7x, right? 3x and 4x are like times. We can combine them by combining their coefficients. So we have a 7x on the left, right? Yeah. One more step to isolate x on the left. Coefficient of x is 7. So we divide both sides of the equation by the coefficient of x, 7. So we cancel. We have x equals 42 divided by 7 is 6. All right, yeah, that's how do we handle this problem. Most of you got it done correctly. So that's good. Very good. That's number 5. Let's move on to number 6. Number 6, let me copy the equation here. We are solving 8y plus 3 equals 2 plus 5y. 2 plus 5y. Let me double check. 8y plus 3 equals 2 plus 5. Yeah. So we are solving the equation for the variable. What's the variable in this case? What's the variable in this case? We don't have the x, right? Yeah, y. Yeah, the variable doesn't have to be x. Are you guys doing the homework in My Life Math? We already finished chapter 1, okay? We're done with test 1. We actually already done test 2, chapter 2 already. So you should have those assignments, those 2 chapters assignments done by now, okay? Am I clear? Yeah, you need to do the assignments. Doing the assignments is also a preparation for tomorrow. I'll give you a couple minutes. Please work on this problem. Solve the equation for y. y is the only variable. Give you a couple minutes. We are going to use two different methods to handle this problem in a moment. After you guys try first. You guys try first. Like it seems like you like this method. That's correct. So ay equals -1 plus 5y. But you need to have a goal. What's your goal? Your goal is to isolate the y on the left, right? Isolate the y on the left. Now you have 5y on the right. You need to get rid of 5y from the right-hand side first. How do you get rid of it? Yeah, exactly. If you like that method, that's totally fine. That's a good method. That's addition property of equality, right? That's what we learn. Actually, using my method to transposition of terms. That's also the 3y equals perfect. Very good. Very good. So which method you are using? You do have to have a method. So what is that? What is the 5y minus 5y? What is 3 plus 3? You cannot combine them when they are on different sides of the equation. You only can combine them when they are on the same side, right? So you have to move them around. You can, whatever method you like to use. Let's see. So you move it, but you forgot. Hold on. Yeah, but you forgot one thing. Think about what you forgot. Transposition of terms, move it and change the sign. You forgot that, right? You move 5y over, you're going to change -5y. Yeah, very close though. That's good. You move it correctly. Yeah, but remember, every time you move a term from one side to a different side, change the sign to the opposite. Yeah, very close. Good job. What is 2 minus 3? Be careful, yeah. Mathematics is very strict. We learn math to learn being careful, right? Yeah, what's your final result? You don't have to, it's a multiple choice question, right? When you look at the ABCD, I do not use decimal, especially when it's non-terminating. You guys. Perfect, that's correct. You have an answer? Okay, yeah, perfect. All right. So most of you get this done correctly as well. That's great. So I'm going to show you two different methods. All right. But doesn't matter which method, the same goal. You're gonna be clear. You are isolating y. Sorry, you are isolating y, the variable, on the left, right? You are isolating y on the left. So when you see 5y on the right, you have to move it over because you don't want a 5y stay on the right-hand side, right? So the first method, you can do this. You don't want a 5y stay on the right-hand side. You can minus 5y from the right, but you have to do the same thing to the left. So you subtract 5y from both sides. And then let's see what we have. You bring down 2. 5y, negative 5y cancel, right? On the left, 8y minus 5y, you have 3y. 8 minus 5, 3y, and bring down 3. Correct? Yeah. You want to isolate the y on the left. Of course, this is constant. You need to get rid of this constant, -3 on the left, from the left, right? Opposite of +3 is -3. So you can -3 from both sides. On the right, 2 minus 3, -1. On the left, +3, -3 cancel. So you have 3y on the left. One more step. Divide both sides by 3, which is the coefficient of y. 3 cancel 3. We have a y isolated on the left. On the right, we have a negative 1/3. Another method, we use the transposition of terms that I try very hard to show you in the class, Yeah, I can color them. This blue term, green term, this be green. Green term, orange term, purple term. So you can see we have 4 terms in the equation. 4 terms in the equation. Blue and green are variable terms. They are like terms, right? Orange and purple, they are constants. So we are going to use the transposition of terms to collect like terms. I emphasize it many times. The equal sign is like an anchor, right? It's gonna stay here, the anchor. What happened? What is going to happen about to those 4 terms is the blue term stays. Nothing has changed. The blue term stays on the left. The green term is moved over to the left. So you have to remember to change the sign to the opposite, right? Yeah, you move 5y over, the green term will move to the left. That's perfect. But you need to remember to switch the sign to the opposite. Okay, super, super important. Knowing it's a multitask. Not just move it over. You have to flip the sign in it. On the right, we have 2. Stay on the right-hand side. And then the orange term, we wanted it to the right, right? So you move it over. But remember to change the sign. Yeah, I want you to take time to look at this step. What happened to those 4 terms? Yeah, this is the anchor, the equal sign. Left-hand side, right-hand side. What happened is the blue term remains the same. Nothing changed. Green terms change the sign, right? So green term change the sign as well. What I'm trying to say, when you change the side of the term, you have to change its sign as well. So first again, yeah. And on the right-hand side, the purple term remains the same. The orange term changed the sign. It was on the left, and now it's on the right, right? But you have to change the sign in front of it. Yeah. By doing this, we collected like terms. Those 2 are like terms on the same side. These 2 are like terms on the same side, right? We cannot combine like terms if they are on different sides. We have to put them together in order to combine them. Now we are ready to combine them. On the left, 8y minus 5y. 3y, right? 8 minus 5 is 3. 2 minus 3, negative 1. Divide both sides by 3, y equals negative 1/3. Okay? Yeah, practice those problems 5 times. If you are not feeling comfortable, after 5 times, you will feel a little bit more comfortable. Repetition make a difference. Let's see next problem, number 7. Let me copy this problem and then we practice. It is 5 times parentheses x plus 3 equals 5x plus 15. All right, give you a couple minutes. Solve this problem. Solve this equation. There are 2 parentheses. In chapter 1, we learned a property. We can use the property to remove the parentheses. The property is called distributive property. A times B plus C equals A times B plus A times C. apply distributive property first, and you are solving this equation. This will happen. The parentheses is like walls, right? You have to break them, and you can free them, free those terms, and you can move them around, combine them. What you have. Yeah, very good. You apply the distributive property correctly. And did you guys see something special about this equation? Huh? When we learn this part, yes, that's correct. Distributive property. Okay, so 5 times x, 5 times 3, positive. Very good. What's your solution? The solution is not 0. Yeah, what's the solution? It's not nothing. This is the identity. It's 0 equals 0, right? Remember when we learned linear equation in one variable, I showed you a table. We can categorize or classify linear equation in one variable into 3 types. We have 3 types linear equation in one variable. Conditional, identity, contradiction. Do you guys remember that? Yeah, conditional, the equation only has one solution. Identity, the equation has infinitely many solutions. Contradiction, the equation has no solution. Does that ring a bell? Yeah, so let's look at this equation together. Left-hand side has a parenthesis. If we apply distributive property, 5 times x, 5x, 5 times 3, 15. Right-hand side also has a parenthesis, but obviously the coefficient is 1, right? We talked about this before. If the coefficient of the parenthesis is 1, we can literally remove the parenthesis. And what actually you see right now? 5x plus 15, 5x plus 15. What is that? This equation is an identity. Means what? Left-hand side always equals the right-hand side, no matter what x equal to, right? Because they are exactly the same. 5x plus 15, 5x plus 15. And you don't have to continue all the same. This would be enough for us to determine, to see this equation is an identity. And no matter what x equal to, you let x be 0, left-hand side is 15, right-hand side is 15, they are equal. You let x be 1, left-hand side 20, right-hand side 20, they are still equal. You can try. Yeah, no matter what value you give x, the equation always holds. So infinitely many solutions. All real numbers are solutions of the equation. Okay, the equation is an identity. Let me show you for this problem. Tomorrow, what are you going to choose? So the answer you're going to choose is identity. Many solutions. Actually, infinitely many solutions. Okay. So when you look at the A, B, C, D, the answer choices, if the equation is an identity, you're going to choose infinitely many solutions. Am I clear? Am I clear? Yeah, tomorrow, when you see a problem, when you try to solve the equation, you find out the equation is an identity. Then the solution, you're going to choose, the answer, you're going to choose infinitely many solutions. So good? Next up, number 8. Number 8, I'm gonna ask you to solve this equation. 5 times parentheses x plus 2 minus parentheses 5x minus 10 equals 0. Okay, I give you a couple minutes. Work on this problem. Solve this equation. Solve this equation. You see 2 parentheses, so you're gonna apply distributive property again here. Distributive property A times B plus C. equals A times B plus A times C. How do you remove the parentheses when the coefficient is -1? This coefficient actually is -1 here, right? So -1 times 5x, -1 times -10. You change all the terms in the parentheses to their opposites. So let's see what you have. 5x plus 10 minus 5x. 5x plus 10 minus 5x plus 10. Yeah. And can you simplify the left-hand side? The 5x, -5x, they cancel, right? What about the two constants? What do you have after that? Yeah. -1 times -10. Very good, yeah. So when the coefficient of the parentheses is -1, after you remove the parentheses, you're going to change all the terms to the opposite. Very good. Very good, very good. Yeah. So do you see those two cancel each other? Yeah. And then you combine the two constants. So what is that? 20 equals 0. Contradiction. So you're going to choose no solution. Yeah, let's look at this problem together. Remove parentheses. The first parenthesis has a coefficient 5. 5 times x, 5x. 5 times 2, 10. Second parenthesis has a coefficient -1. -1 times 5x, -5x, right? -1 times -10, +10. Is actually easy. If the coefficient is -1, you simply just change the terms to their opposites. 5x becomes opposite -5x. -10 becomes opposite of +10. On the left, those two like terms, yeah, they cancel each other, right? 5x minus 5x, you got a 0. 10 plus 10, what is 10 plus 10? 20. So we got a 20 equals 0. And what is that? Is a contradiction. Then from A, B, C, D, you're going to choose no solution. No solution. Yeah, we talked about this when we learned this part. I showed you the 3 types of linear equation in one variable. We have a conditional, identity, contradiction. Number 8 is a contradiction. So the answer, you're going to choose no solution right here. All right? Is that clear? Okay, let's continue. Number 9. Translate. Translate the sentence into an equation using the variable x. Okay, we are looking at number 9, okay? Number 9 is here. We're looking at the number 9 right now. Translate the sentence into an equation using the variable x. Let's see what sentence. The sentence is the product of a number and 5 is 10. The product of a number and 5 is 10. Yeah, so you are translating the sentence in English to algebra. Yeah, look at is 10. What is is 10? Equals 10. Very good. Equals 10. What equals 10? Equals 10. Is 10 means equals 10, right? A product. Product equals 10. Product of what and what? A number, we can let the number be x, right? Yeah, we can let the number be x. Yeah, the product of x and 5. How do you how do we write the product of x and 5? X plus 5, x minus 5, x times 5, right? Or 5x, correct? Yeah, so the sentence after we translate, it is 5x equals 10 here. Is 10 is equals 10, right? The product of 5 and the number and the 5 times x equals 10. Okay, yeah. Yeah. Is this clear, number 9? Is that doable? Okay, number 10. Let's see number 10. Number 10, the difference between two, the number 10 is an application problem. Is an application problem. So I'm going to copy paste. We're going to solve it somewhere else. Let's do it here. Oops. Doesn't let me paste. Okay. The difference between two positive integers is 10. One integer is twice as great as the other. Find the integers. That's the goal. Yeah, find the integers, right? So we're gonna bring in variables. Yeah, we have two integers to look for. What do you want x be? Let x be what? The two integers must, one is smaller than the other is bigger, right? Yeah? Do you want x be the smaller number or the bigger number? You tell me, huh? The bigger number? How about smaller number? Yeah, maybe smaller number is easier for you. Otherwise, you have to handle fraction. Yeah, so how about let x be the smaller number? Be the smaller number. Be the smaller integer. Then then the bigger integer? Then the bigger integer is what? Yeah, is what? Let's see. Look at this sentence. One integer is twice of the other. Yeah, one integer is twice as great as the other. Okay? Yeah. So the two integers, one is twice of the other. So if we let x be the smaller integer, what's the bigger integer here in terms of x? Twice of the other. Yeah? What is it? Twice. If the smaller number is x, what's the bigger number? The bigger number is twice of the smaller number. Guys? You tell me. Is that 2x? Yes or no? Huh? Yes. One integer is twice as great as the other. We actually let x be the other, the smaller integer, then the bigger integer is twice of it, so it's 2x, right? Okay, the two integers right now are x and 2x. We need to find the value for x in order to know what are the two integers. How do we find the value for x? Do we need an equation? Do we need an equation? Yeah. How do we create the equation? Let's look at this sentence. The difference between the two positive integers is 10. The difference between the two integers is 10. Yeah, what does that mean? Does that mean the bigger number minus the smaller number is 10? Yeah, difference, right? Yeah. So the bigger number minus the smaller number, the difference is 10. That's the equation. Yeah, I model this problem for you. Tomorrow, you will have to model your own, on your own. Yeah, the beginning part that you bring in x and then set up the equation, that's the harder part. The solution, solving the equation part is easy. I give you 1 minute and you tell me what is x. This one is super easy. I don't think you need 1 minute for that. 1 second. What is x? left-hand side 2x minus x. What is 2x minus x? It's x, right? X equals 10, yeah. So if x equals 10, what's 2x? If 20, yeah. So the smaller number is 10. The bigger number is 20, yeah. So you're gonna look at A, B, C, D. You're gonna choose the one saying the two integers are 10 and 20, yeah. And how do you check if your result is correct? You bring the answer, bring the result into the original problem. Yeah, let's see. The difference between the two numbers is 10. Yeah, 20 minus 10 is 10. One integer is twice greater as the other. 20 is twice of 10. That's it. You know, I do not worry about this problem because it's a multiple choice question. The worst case, what do? You apply method of elimination. You look at A, B, C, D. For example, A gives you two numbers, right? You bring those two numbers in the problem to see if they satisfy the conditions in the problem. If not, you continue to look at the D until you see the two numbers satisfy all the conditions in the problem. Do you see what I'm talking about here? Because you have it's a multiple choice question. You have answers to check. Any question about number 10? Let's continue number 11. Number 11 is also an application problem. Yeah, I'm going to cover this part. Yeah, let's look at it here. Number 11. 20% off what number is 30? OF here means multiply, okay? OF here means multiply. We can let x be the number. And we can translate the sentence as 20% off. So 20% times x, right? 20% off means 20% times x, right? Is means equal, right? Equals what? Equals 30. And what is 20% in decimal? What is 20% in decimal? Converted 20% as decimal, what do you have? 20% as decimal. 20% is 20 over 100, right? 20 over 100, what is 20% as decimal? 0.2, yeah, so you have 0.2 times x equals 30. How do you solve for x? How do you solve for x? Divide by 0.2, right? Correct? You cancel, you have x on the left. Calculator, use 30 to divide it by 0.2. Tell me what you have. 150, yeah. So the number you are looking for is 150, 150. Is that doable, number 11? Okay, very good. Yeah, I have the solution right here in the problem. Let's see number 12. Number 12, what is 50% of 200? Yeah, this one is even easier. What is 50% of means multiply, right? 200. And you tell me, what is 50% of 200? 50%, 55%, sorry, 55%. Can you convert 55% to decimal? Convert 55% to decimal. What is it? 0.55. Perfect. Use your calculator. Multiply 0.55 by 200. And let me know what you have. Yeah, calculator. Multiply 0.55 by 200. What do you have?
Angela, what do you have? Huh? 110? That sounds right. Very good. It's 110, okay? Yeah. You need to know how to convert a percentage to decimal. And also you need to know OF here. OF here means multiply. That'll be good enough. That's number 12. Number 13. Oh, number 13 is a mixture problem. It's a mixture problem. Let's see if we can explain this problem here. How many liters of a 60% alcohol solution must be mixed with 70 liters of a 90% solution to get a 70% solution? So here, alcohol solution. When we had an example about the mixture problem, that is the acid solution. Do you guys remember? And this is the alcohol solution. But the number is different, solution is different, but the way we process it is the same. So what happened is you have 70 liters, 90% alcohol solution. And you need to figure out how many liters is 60% alcohol solution to get the mixture, which is 70%. So we let X be the amount of 60% alcohol solution you need to use. So here you have X liters, 60% solution. You're gonna mix that with 70 liters, 90% solution to get 70% solution. So look guys here. When you pour X liters here, when you pour 70 liters here as well, how many liters solutions in the jar? You pour X liters here, right? And then you pour 70 liters here. How many liters solution in the jar? You pour X liters here, and you pour 70 liters here. Do you put X plus 70? Yeah, X plus 70, right? So the liters of solution in the jar is X plus 70. Okay, so the alcohol solution has alcohol and water, right? Let's see how many alcohol do we have in this blue. 60% times X. That's the solution. That's the alcohol in the blue, okay? Yeah, so this is the alcohol in the blue, 60% times X. 60% times X, that's how many liters alcohol in the blue. 90% times 70, that's how many alcohol in the green. Add them up, we have the amount of solution, amount of alcohol in the jar, in the blue jar, It's right here, 70% times X plus 70. And then you solve this equation. Do you guys remember this? It's super similar with the one we explained before. Do you think you can do this? Yes or no? Okay, then I'll give you a couple minutes. You guys solve this equation, okay? You guys solve this equation. Do you understand this equation, firstly? Do you understand why that equation is true? I'll give you a couple minutes, solve this equation. This problem is pretty time consuming. Do you have the value for x? You can get rid of the percentage symbol at one time. All the three parts in the equation has a percentage symbol. And let me know, do you have a value for x? What is x? Do you have x equals to 140? Okay. You make sure you practice this problem, okay? It's very time consuming. I would recommend that you look at the note of the mixture problem we talked about before, and also look at the review. I will post that very soon. Can we continue? We only have half an hour now. We still have a lot of problems. We still have half of the problems. 14, multiply by power of 10. 14 and 15, I do not worry about that at all. It's easy. Number 14, 23.456 times 100. Just use your calculator, okay? And you won't miss it. You cannot miss it. Use your calculator. Here, I want to show you multiply a decimal by 100 is equivalent to move the decimal point to the right twice. Number 15, multiply a decimal by 1,000 is equivalent to move the decimal point to the right 3 times. I don't think we need more time for number 14 and number 15 because use your calculator, okay? Number 16 and 17. 16, we need to find the least common denominator of the fractions. Negative 1 over 20. The other fraction is 1 over 60. What's the least common denominator? Least common denominator of the two fractions is the least common multiple of the two denominators. So we are looking for the least common denominator. We are looking for the least common multiple of 20 and 60, which is 60 because of the special case number 1, right? 20 is a factor of 60. 60 is a multiple of 20. 60 is the smallest multiple of the self, so 60 is the smallest common multiple of both. Is that doable? Those problems are pretty straightforward. Number 17. Tell me what's the least common denominator of 1 over 7 and 1 over 10? 70. How do you get a 70? The least common denominator is the least common multiple of the two denominators, right? Yeah, 7 is 7. 10 is 2 times 5. You can see the two numbers are mutually prime. Yeah, when the two numbers are mutually prime, LCM is their product. 7 times 10 is 70. Okay, these are very easy. Number 18. Okay, number 18, I give you a couple of minutes. Please solve this equation. This equation has decimals. How many terms in the equation? How many terms in the equation? I see this term. I see this term. I see this term, right? I see 3 terms. Yeah, give you a couple minutes. Please work on it.
How do you deal with the blue term? Do you just copy it down? You don't change it at all, right? How do you deal with the green term? Do you move it over? You move the green term over, right? Everybody? Yes? So negative 1.1x becomes positive 1.1x on the left. On the right hand side, we still have negative 22, correct? Okay. Could we combine the blue term and the green term and tell me what you have? Negative 2.2x plus 1.1x. What do you have? Negative 2.2 plus 1.1. Positive or negative? Negative 1.1x. And how do you continue from here? Divide both sides by negative 1.1, right? And what is x equal to? Positive 20? Positive 20, right? Yeah. Make sure you have the same thing, everybody. Okay. Number 19 is to solve the equation with fractions. Yeah, this might be challenging. Let me copy this right here. 1 over 3x minus 7 equals 1 over 4x plus 8. Yeah, I would give you a little time. You work on it on your own first, and then we look at it together, okay? Yeah, this equation has fractions. Yeah, I know you don't like fractions. How about we get rid of the fractions at the very beginning? Get rid of the two denominators at the very beginning. How do we do that? How many denominators do we have? 2, 3, and 4, right? What's the least common multiple of the two numbers? Huh? 12, yeah, okay. You are going to multiply each single term in the equation by 12. Yeah, please do that. Multiply each single term in the equation by 12. Please do that. Since we only have 15 minutes, I guess I want to give you enough time to practice, but seems like we have to hurry up. Multiply by 12 equals 1 over 4x multiplied by 12. And the second term on the right, 8 times 12. Okay, all the three terms times 12. All the three terms times 12. Okay, on the left, look at this diagonal. 3 and 12. Yeah, we multiply 12 to eliminate the denominators. So here, 3 will become 1, right? 12 will become what? You tell me. Do we have a 12x here after we multiply by 12? I'm sorry, 4x, my bad. After we multiply by 12, do we have a 4x here? Yes? Second term, calculator, tell me what is 7 times 12? Negative 84. Right hand side, tell me what is 12 over 1 times 1 over 4? 4 becomes 1, 12 becomes 3. Do you have a 3x after you multiply by 12? Yes? And on the right hand side, the second term, what is 8 times 12? Okay, how many terms right now? How many terms right now? 4 terms. You're gonna solve x, okay? Yeah, transposition of terms. I'll give you 1 minute, and you're gonna tell me what is x. You're gonna tell me what is x. You're gonna tell me what is x. You can use the transposition of terms.
is a very convenient method.
So once you find those denominator,
Yeah. Because you don't like the fractions, then get rid of the denominator at the very beginning. So what do you have for x? 180. Okay? Yeah, practice. Number 20 is also a problem with fractions. Okay, let's look at this solution quickly. Yeah, I guess I went too slow in the beginning. This equation has how many denominators? 2, 3, and 9, right? What's the least common multiple of 3 and 9? 9, because the first special case, right? Okay, then we are going to multiply all the three terms in the equation by 9. The first term, 9 over 3 is 3. Second term, 9 over 9 cancels, you have -2x. Right hand side, 5 times 9, 45. Left hand side, combine like terms, 3x minus 2x, we have x. So x equals 45. Is that easy? And similar with the earlier. Two problems involving fractions. Number 21. Graphing this inequality. Yeah. Write each inequality in interval notation and graph the interval on a number line. X is bigger than -5. We need a graph all the real numbers greater than 95. So we go to the right? At 95, since 95 is excluded, we have a parenthesis. The interval is from 95 to past infinity, open. Is that clear? Yes? Number 22. Same thing. All the real numbers no more than 10. Less than or equal to 10, right? So let's say here is 10. So we're going to go all the way to the left, right? All the real numbers to the left of 10. At 10, we have a bracket because 10 is included. X is less than or equal to 10, right? Less than 10 or equal to 10. Since 10 is included, we have a bracket. So the interval is left open, right close. Is that clear? Okay. Where is the tables here? Say again. Number 22. X is less than or equal to 10, right? X is no more than 10. So this inequality represents all the real numbers less than 10 or equal to 10. So did I answer your question? Okay. Number 23. This inequality tells us all the real numbers bigger than 0, no more than 6. Let's say this is 0, this is 6. So all the real numbers in between exclude 0, include 6. So this is a left open, right closed interval. Finite interval. Okay, left open, right closed. So you were not here when we learned this part, right? So yeah, I think that's the reason. I published all the class videos. You need to watch them. Number 24, solve inequality. Give you 1 minute. When we learn this part, we say the only difference between solving an equation and solving an inequality is when we multiply or divide both sides of inequality by a negative number, we have to what? Switch the direction of the inequality symbol, right? Okay. Tell me what you have. -5x less than or equal to 10. How do we isolate the x on the left? How do we divide by? Okay. Divide the left-hand side by 95. Divide the right-hand side by 95. Do we need to do something? Yes, switch the direction of the equal symbol, right? So we have x isolated on the left. Is bigger than or equal to, what's 10 over -5? Huh? What is 10 over -5? -2. So the solution set include all the real numbers no less than -2. So bigger than -2 or equal to -2. Let's see the graph. If this is a real number line, and this is a -2, then all the real numbers bigger than or equal to -2, right? That's the graph. So the interval is negative close, right open. Questions? Are we clear about that? Some of you need to watch the video because you missed the class. Number 25. You did number 25 yesterday, but I want you to do it again. Number 25. -7x plus 6 minus 7x is less than 10 minus 20x plus 2. I give you 2 minutes. Yeah, we only have 6 more minutes left, so 2 minutes for this one. Solve for -7x plus 6 minus 7x less than 10 minus 20x plus 2. Isolate x on the left. Simplify each side first. Simplify each side of the inequality first. Excuse me. Okay, simplify the left-hand side. You should feel familiar because we did the same thing yesterday. How do we simplify the left-hand side? -7, -7. Do we have a -14x? Right-hand side, 10 plus 2. Yeah, so we have a blue term, green term, orange term, purple term. And we're gonna apply transposition of terms to collect like terms. Bring down the blue. Nothing change. Move over the green. Negative becomes positive. Bring down purple. Nothing change. bring over orange, positive becomes negative. Do you see what happened here? Okay, very good. And we copy the inequality symbol. Left hand side, tell me please, what is the negative 14x plus 20x? Right hand side, what is the 12 minus 6? Divide both sides by 6, what do you have? X is less than 1, right? Yeah, did you do the same thing yesterday? Yeah, so the second time when you do the same problem, you feel a lot easier, right? Yeah, just to repeat. The last problem, compound inequality. I'll give you a couple minutes. Solve this compound inequality. You did the same thing, I think you did this as well. Three x is in the middle, right hand side is 30, left hand side is 12. When we solve a compound inequality, we try to isolate x in the middle, right? Isolate x in the middle. Yeah. How do we isolate x in the middle? We need to get rid of 3, right? Hold on. Do we need to switch the direction of the inequality here? No, why? Because 3 is a positive. Yeah. So we have x in the middle. What is 30 divided by 3? What's 12 divided by 3? Okay. So when you graph, yeah, I kind of like the black background and the white color of a pen, right? I feel like this is pretty interesting. Okay, so let's say this is a real number line. This is a 4, this is 10. All the real numbers in between. At the 4, we have a parenthesis because the 4 is excluded. At 10, we have a bracket because 10 is included. So the interval, so the solution set in the interval notation, is 4, 10, open, close. Any question about this problem? Okay, I would recommend 5 times. Yeah, repeat those examples 5 times for each to get ready for tomorrow. Thank you guys for coming today. I'll see you tomorrow.